Hello everyone, and welcome to this video where I'm going to demonstrate to you some example of inverse kinematic created in OpenGL with the CCD technique algorithm. So this is for my class in Trinity College in real-time animation. So the first thing I want to demonstrate to you is the inverse kinematic with two bones in 2D only, so two bones and two joints. So you can see in the screen that there's two wooden sticks stick to each other, and the end effector of this object is the orange ball, and the target is the green ball. So if I move it in 2D only, we can see that this object follows the target and tries to find the most optimal way of reaching it. And for the unreachable positions, we can see that it does extend to the maximum, so it works. Now let's see how this model behaves in 3D with 3 joints this time. So the algorithm is the same, the CCD, but I'm also now moving the target in 3 dimensions, so with the Z-axis this time. So you can see that if it's still in 2D, it still does work with 3 links. And if now I move it in 3D, it also follows correctly this target and finds the correct orientation for each links. And once again, there's no unreachable position here actually, but there's some. If I go up the maximum, you can see that it starts to extend to the maximum until you can reach it. So this is for the 3D version. As a bonus for this 3D part with 3 joints, I also decided to to use a model, a real model, like a very realistic model for this with constraint. So I added some constraints to the different links so that this arm on the left, on the right, would have some real constraint realistic for a human arm. So you can see that if I move it up, there's 3 links, the hand, the forearm and the arm, and we can see that the hand doesn't go the whole way rotation, and also the arm is stuck because I added a constraint that it cannot go this much. Same applies here. And in 3D it also works. So this man is trying to reach this target and gets stuck because I added some constraints too. And if I move back, it also constrains because it cannot move anymore behind because the human arm cannot go this far. So this is for the enhanced model with a better looking graphics and also a constraint of this feature, the 3D feature with 3 bones. And now for the final feature, the feature that asked for an animation for the end effector. I decided to take the same models that for the 2D part of the 2D feature, like 2 sticks, and to replace the orange ball by a hand that would move when it reaches the target. So if I move it, you can see that it follows it correctly like the other one, but if the hand can reach it, so if it's close enough, the hand is closing and it keeps closing while you are on the good next to it. And if I remove it, it stops because it's not far enough to grab it. and it also obviously works in 3D. So if I make it reach it again, it tries to grab it. So for this I used a rigged model of a hand that I rigged myself, and I did some keyframe animation to it too. So you can see in Blender here that I have my keyframes for each bones of my arm, my hand, and that it plays the animation I wanted to create. So for that I'm using lerp interpolation for the position scaling, and also S-lerp, so spherical lerp for the rotation, because I'm using quaternions for the rotations of the parts of the bones. Thank you very much for looking at this video.